Welcome back. What we got going on today are, well, let's start with this. You're gonna have to hit pause pretty quickly. Observational study designed experiment. We've already talked about them. What I want you to do is go back. Well, I shouldn't say go back. In a moment, you're gonna hit pause and I want you to go to the reflection response form and I want you to identify what does an observational study show? What does a designed experiment show? So hit pause now, put that in the reflection response. What can you learn from observational studies? What can we learn from designed experiments? Do that now, then unpause, and then come back. And if you don't remember, then you gotta go back to a last video and figure that out. Hit pause. All right, welcome back. Some of you might be wondering, what is up with wearing the earbud while you're doing this? Well, I have found that the little microphone in here does a better job than the microphone on my laptop. Therefore, it's picking up my sounds a little bit better. So I'm trying this out for a while and see how it goes. All right, so in a designed experiment, which is what we're going to be doing now, in a designed experiment, we're going to start by talking about variables. Now, in the past, when we've done linear regression, we said explanatory, response, and then there's actually a third variable. So explanatory variable, to remember, is that variable that we think helps to explain the outcomes. So we think that this variable explains what we see happening in this variable or the response. So the change or influence that we're measuring as a result of whatever this variable is. But there are other variables. There are always a lot of variables that go on. And you try your darndest, which is what we're going to do now, to eliminate all of those other possible variables, but there still could be this other lurking variable. And maybe that other lurking variable also is part of the cause. So the explanatory or explains, maybe this is also something that explains. And the two of them together cause this change. Okay? So maybe these are the causes and they both cause that effect. And that's what we do designed experiments for, is to find out how does this explanatory variable actually affect this response variable. All right, so here we are with doing a design. So let's just say we got 600 people who have high blood pressure. Okay, high blood pressure. And we're going to test some things. So first thing we're going to do is we're going to say, oh, obviously men and women are different. So let's make these first two. Let's say there's 300 men and 300 women. And half of them here, so these are the men, women. So the first thing we need to do is we need to take these 300 men and split them into two equal groups. So it doesn't have to be equal, but it sure helps. So I'm going to randomly assign. Now this is different than a simple random sample. So I'm going to randomly assign, and we need to be very careful when we're doing experiments. So we say randomly assigned, pretend I can write the word assign, A-S-S-I-G-N. We randomly assign each of the 300 men into two groups of 150. And we randomly assign the 300 women who have, again, all these people have high blood pressure, so that 150 are in each group as well. And I have two different groups for a reason. Now, maybe we start by doing a block and we say, okay, first goes 300 men, 300 women, and then we split them in half, either way. But then these men are going to get a treatment. And so up here I'm going to write treatment. So the first thing we always do in a designed experiment is we randomly assign them to groups. All right, and then these 150 subjects, so the people themselves, when we're talking about a designed experiment, are called subjects. If we're not talking about people, let's say we're doing this test on lab rats, they would be called experimental units. Very kind of generic term, but experimental units would be if we're doing this on rats or on plants. Let's say we're doing something on fish or on soil samples. Those are my experimental units. They're randomly assigned, so random assignment, into, in this case, I've got 4 different treatments. This treatment will be, let's say they're getting a 100 milligram pill. This one they're getting a 150 milligram pill. All right. And then here, the women are getting 100 milligram. So really, there's only 150. Let me finish that down. All right, so there's other things like, are there other, in this case, there's levels. There are 2 levels, 100 milligram or 150 milligram. There's treatment. So the I hem and I haw and I hesitate because the language is going to vary from question to question. So treatment itself, it says, let me read you what one definition is. A specific condition applied to an individual is called a treatment. All right. So in this case, the specific condition that's being applied is they are being given a pill. All right. There are 2 levels to that pill. So there are 2 levels to the treatment, but there's only one treatment. They're being given a pill. Now what I'll get to that in a second. All right. If there are other things that I'm taking into consideration, maybe I split it up and earlier instead of men and women, it was certain, first they say, well, really high blood pressure versus semi-high blood pressure or something along those lines. Then there would be another factor that goes into play. As we do some of the problems in the work, we'll be looking at what is the treatment, what are the levels, are there any factors, who are the subjects, were they randomly assigned? But all of that goes into a designed experiment in the language of a designed experiment. We'll do more, don't worry. And then after they get that treatment, we always have to, at first, compare. So we're going to compare amongst the men to see if one is better than the other. Compare amongst the women to see if one is better than the other. And then we will compare our results at the end to see was there a difference between the men and the women. So not just was there a difference between the men, the 2 treatments, between the 2 treatments and the women, but then also is there a difference between how each gender sees what happen? Okay? Now, when we're doing it, some other things to think about. When we're dealing with people, it's best, and we should have done something more like this. So let's say we're going to get treatment A, treatment B, and these are going to be people here, PPL for people, and then treatment P. P stands for placebo. Some are going to get treatment A, and we're going to see their response. Some are going to get treatment B and see the response. And some people are going to get a placebo, which is also considered to be a fake treatment. All right, why do we do that? Because it's mind over matter. People, if you give them a pill and say, hey, this will help with your headache, are likely going to not or feel less of an effect of the headache. Now, it might get better quicker with treatment A or B, but it's very likely that people will still see a response if they take something, even though it's actually nothing. Now, what's key here is this has to be a blind experiment. That is, people can't know which one they're getting. Because if you tell them, hey, here's a pill that's fake, it doesn't do you any good. So you give them a pill and say it's the real thing, and then they get better. But then you still compare, and hopefully, when we compare at the end, A and B did a better job, quicker, or lasted longer than the placebo effect. All right. Now, if the person giving them the pill also doesn't know, that's what's called a double blind. Because again, you don't want the person giving the pill to be like, hey, here's a pill, wink, if they're giving them the placebo, because that would be counterproductive to what you're trying to do. All right. So when the subject does not know, it's called blind. When the subject and the person administering the treatment don't know, it's called double blind, which is even better if you can do double blind. Do we need double blind when we're doing tests on rats? No. Do we need double blind when we're doing tests on soil samples? No, because the soil samples don't matter. They can't think. But people can think. Treatments, experimental units, levels. I could be doing different levels of treatments, different factors that go into it. Maybe it's with people giving a medication A and monitoring their diet, treatment B and not monitoring their diet. So then that would be different factors that go into each treatment. So here there's 3 treatments: treatment A, treatment B, and the non-treatment of the placebo. And then I could have different layers of treatment A or B, levels I should say. Maybe treatment A has, again, 150 milligram and 200 milligram. I'll do the same thing here. I'll keep the placebo as flat because it doesn't matter really if there's only one placebo. Then I could also look at, maybe there's people who are under a certain weight and over a certain weight, under a certain weight and over a certain weight. So that's another factor that goes into all these different treatments that I'm going to do, comparing them as time goes on. Last thing, if you were given a scenario, I want you to think, it's related to what you did at the beginning of the video. What would be some tip-off words? How would you know if what they're looking at and what they're talking about is observational, or is it an experiment? So think, how would you tell the difference? Now, don't use the word observe in observational when you're doing it, and don't say it's not observational because it does something for an experiment. But what are some tip-off words that you might see that would say, yeah, what they're talking about right here, that's an experiment. Or, nope, that was definitely an observational study, so that you can figure out how to delineate. That's what I want you to write also in the reflection response. So the first question was, what's the difference? What can you show or prove with an observational study? What can you show or prove with an experiment? And then the second half is, how do you know? What are some tip-offs? We haven't done any of these problems yet, so I'm asking you, what do you think would be a tip-off that what's going on is observational or an experiment? That's all, folks. I will see you in class.